Hey everybody, so today we're going to talk about inverse functions. The inverse of a relation is the set of ordered pairs obtained by switching the x and y coordinates of an ordered pair. So here I have a relation, 0, -3, 1, -1, 2, 1, 3, 3, and 4, 5. If I want to find the inverse of that, all I do is switch the ordered pairs. So -3, 0. 1, -1 becomes -1, +1. 2, 1 becomes 1, 2, and so on. Now this is kind of weird because 3, 3 is just 3, 3. And you'll kind of see why in a minute. This one becomes 5, 4. Okay, so this is my inverse right here, which I usually write like this, f inverse of x. Okay. This is your inverse sign right here. Okay. Now, the graph of an inverse is always a reflection of the graph of the original equation in the line y = x. So here's my original points. Okay. This is 0, -3, 1, -1, 2, 1, 3, 3, 4, 5. If I want the inverse of that, -3, 0, that's going to go right here. Okay. -1, +1 is going to go right here. 1, 2 is going to go right here. 3, 3 is going to go right there. Notice it landed on the original point. Why is it on the original point? Because it's on the mirror. Just like if I'm looking at a mirror and I reach out and I touch the mirror, okay, the reflection of my finger is touching my finger right on the mirror. And then 5, 4 would go right here. And you can see these are reflections of each other in this mirror right here. Okay, how do you find the inverse of a relation? Okay, so I've got a relation here, y = 2x - 3. I always like to graph that. Okay, so 2x - 3 is right there. Okay, got a y-intercept of -3 and a slope of 2. Now, where did it go? Oh, I just changed its color, I guess. Okay. Actually, I meant that to be blue. There we go. Got to grab the pen and change it to the color first. Okay, there we go. All right, so y = 2x - 3. I'm going to switch my x and my y. And I'm going to solve for y. So I'm going to add 3 to both sides, and I'm going to get 2y = x + 3. You might notice that I like to have my y's on the left side, so I switch those. I'm going to go ahead and divide by 2, and y is going to equal 1/2 x + 3/2. That should be my inverse. Okay, so if I go over here, 3/2 would be right there, and there is my inverse right there. Let's go ahead and let's make this all orange right there so it matches the graph. Okay, so you can see here's my mirror, and they touch at the mirror, and as this goes away at the same rate. Okay, same thing here. So they are reflections of each other. Okay, on this one here, find the inverse of the function f of x is 3x - 1. I'm going to have you go ahead and pause the video and solve this one on your own, and then turn it back on and see if you get the same thing I did. Okay, so first thing, I'm going to go ahead and graph my 3x - 1. That should be right there. Okay, and now I'm going to go ahead and, oops, that's not what I meant to do. 3x - 1, that's right there. Okay. So then we'll go ahead and switch the x and the y. I'm going to add 1 to both sides. I get 3y is x + 1. And then I'm going to divide by 3. And I'm going to get y = 1/3 x + 1/3. Okay, so that going to have a y-intercept of 1/3 right there. There it is. Okay, so we'll go ahead and make this all purple like that one. Okay. So again, you can see they are an inverse of each other. Hopefully that's what you got. Okay. In both those examples, those things were all functions. The original function, or the original relations of function, and the inverse was also a function. In this case, that's not going to be the case. Okay. This is a parabola. It's got a y-intercept of 1. Okay, so if I go graph that right there, there's my parabola x squared plus 1. Okay, now, if I switch my x and my y, okay, and I solve for y, so I'm going to get y squared is x minus 1, and then I'm going to square root both sides, and I'm going to get y equals plus or minus the square root of x minus 1. Okay, so if we go ahead and graph that, that's going to look like this. Should have made this purple, I guess. Okay, so if I plug in 1 to this equation, 1 minus 1 is 0. I square root that, I get 0. Okay, if I plug in 2, 2 minus 1 is 1. Square root that, I get plus or minus 1. That would be here or here. Okay, if I plug in 5, I get 5 minus 1 is 4. I square root that, I get plus or minus 2. So at 5, I'm going to get 2 here and here. Okay, so again, you can see this is a reflection of this over this mirror right here. This part is a reflection of this. This part is a reflection of this. Okay, now, this is a function. It passes the vertical line test. However, if I draw a vertical line right here, at this x, I get 2 y's. So that is not a function. So it doesn't work that every time that you have a function, you take an inverse, you're going to get another function necessarily. So, okay. All right, composition functions. All right, so if you've got functions and you need to verify that they are inverses of each other, what you're going to want to do is find f of g of x, and you're going to want to find g of f of x, and you want both of them to be x. Okay, so let's go through an example of that. We've got f of x is 3x minus 1, and g of x is 1/3 x plus 1/3. So I'm going to find f of g of x. So that means I'm going to take g of x, I'm going to plug it into f of x. So I'm going to get 3 times 1/3 x plus 1/3 minus 1. I'm going to go ahead and distribute this in here. And I'm going to get x plus 1 minus 1. And the 1's cancel out and I get x. Okay? So it is not enough to just do this, though. I have to do the other one as well. So I'm going to find g of f of x. I'm going to take f of x this time and plug it into g of x. Okay, so I'm going to get 1/3 3x minus 1 plus 1/3. So I'm going to go ahead and distribute my 1/3 in here. And I get x minus 1/3 plus 1/3, which is just x. Now, what does that mean? Okay, since they both came out to be x, that implies that f of x and g of x are inverses. And you're done. You have to do all of that, including this statement at the end, because this is a proof. Okay. Formula states that the sum s in degrees of the angles of an n-sided polygon is s equals 180 and minus 360. So basically what that means is I've got 3 sides. If I plug that in there, we know that there's 180 degrees in a triangle, but if I plug it in there, 3 times 180 is 540. Subtract 360, I get 180. Okay, if I plug in 4, I get 720 minus 360 is 360, which is how many degrees there are in a rectangle, or a quadrilateral. So what if I want to know, what if I want a formula that will tell me the total, if I know the total number of degrees, it will tell me the number of sides, okay? So all I'm going to do is I'm going to take this function here, s equals 180 n minus 360, and I'm going to go ahead and solve for n, okay? So I'm going to go ahead and, there's my original equation. Oops, nope, that's not the original equation. There it is. Get this one out of here. Okay, here's my equation. S equals 100 and, oh, I'm sorry. That's what confused me. I lost my equal sign here. All right, there we go. Now I'm going to add 360 to both sides, and I get this, okay? So if I go ahead and put that in there, plus 360, plus 360. Well, got to show my work, right? Okay, I get this. The next thing I'm going to do is I'm going to divide by 180 on both sides, and I get this. N, move that over here, equals S divided by 180 plus 2. Okay, divide this by 180, divide that by 180. All right, so what does this tell me? This will tell me if I know the number of degrees. For example, I know that there is 700 and what did I just do? I know that there is 720 degrees in a hexagon. So I should be able to plug that in here and find out that a hexagon has 6 sides. Okay, so that divided by that is 4, plus 2, and is 6. So it works. Okay. And so we're to our assignment. All right, you got a couple of pages there. So enjoy that. I will see you guys later.